Hey guys, welcome back to another science lesson with HeyCare Math and Science. In this video we'll be learning about generators and how they work. So by the end of this lesson we should all be able to explain how electromagnetism works in generators, be able to explain how generators produce an electric current, and finally be able to describe different types of generators and how they work. So there are two main sources of electricity that are used to power up our devices, and this is the battery and the generator. Batteries are used for portable electricity, whilst generators can be used for both portable and non-portable electricity. Batteries are usually used because they are light and convenient, and generators are sometimes avoided because they are more bulky and less convenient. Imagine just carrying one of these portable generators around when you're using your laptop and mobile phone each time. It won't be very convenient. Also, like I said, this image on the bottom right is an image of a portable generator. It can often be seen in outdoor concerts to power up their sound equipment. A downside of the battery, however, is that it only produces a low voltage and current, whilst generators produce a high voltage and current. This means that batteries often can't be used to power up stuff in our house, such as our TV or fridges and other electrical appliances, because it simply won't provide a high enough voltage and current. So batteries are therefore often used for smaller portable devices, like I said, our mobile phones or laptops or anything in that range, and generators are used for larger appliances that need more electricity. So another difference between batteries and generators is the current that they produce. Batteries produce DC, whilst generators produce AC. We've gone through what these are in a lesson before, but I'll just recap on what they are. DC stands for direct current. This means the current flows in one direction and one direction only. Notice in this image it's only moving towards the right or clockwise. In AC or alternating current, the current moves back and forth and constantly changes direction. So that's the difference between DC and AC. Batteries produce DC, generators produce AC. AC is preferred most of the time because it can generate more power than DC. It is easier to transmit, and voltage can be boosted or dropped using a transformer. So to understand how generators work, we need to understand how electromagnetism works, because generators use electromagnetism to transform movement into electrical energy. So electromagnetism is essentially using the movement of magnets to generate an electric current, and these are the two most common ways this is achieved. So the first one is spinning a loop of wire inside a constant magnetic field, which creates a electrical current inside the wire. So this is the bottom left image here. So we can see the two magnets on the outsides of the wire in the middle. So that is our constant magnetic field, and the wire just rotates in between to move the magnetic field, which essentially creates an electric current. The second way is moving or spinning a magnet inside a wire loop. As you can see in the bottom right image here, the magnetic field changes as the magnet moves. In this case, we're moving it up and down. We could also get a smaller magnet in the middle of this loop and spin it, which will also generate an electric current inside the wire. So this is an image of what a generator would look like on the inside. There's a magnet on the outsides here and the electric wire or coil in the middle, and a turbine here that spins, causing the wire to spin, which generates an electric current. So now we're going to go through a couple of examples of generators, and the first one we have here is known as a dynamo. So a dynamo is a small generator that spins its magnets instead of its coils. So like we saw in this image, it's one of these on the bottom right, except we've got a small magnet here and it's just spinning the magnet. Or we can see it as the same as the bottom left, but we have the magnet in the middle and the wire coil on the outside. This dynamo, the small generator, is often used to power bicycle lights, as we can see in the bottom right image here. So the friction between the wheel and the little wheel that spins and pivots causes that to spin, making the magnet in the middle to spin, which causes an electric current in that coil there. Yep, the more common and widely used generator is known as a turbine. You've probably seen some of these before as you've been driving around. They spin at high speeds to generate large amounts of electric current, and there are many different ways to spin turbines. the one on the bottom left here, we're using wind. The one in the middle, we're using movement of water, and in the bottom right here, we're using steam to spin the turbines. So as long as the turbines are spinning, the generators will produce an electric current. So let's start with the wind turbine. The wind turbine uses wind to spin the turbines. And a really good point about this is that it is renewable and clean energy. We don't have to do anything to produce wind, it's just always there, so we're just taking advantage of that wind to spin our turbines. The disadvantages of a wind turbine is that it really depends on how much wind there is to produce electricity. One day, if it's really windy, we might get a lot of electricity, but on less windy days, we won't get much electricity. So it isn't too reliable of a source. Another downside of this is that it is really noisy. If you've driven past a wind farm or been close to one, you'll notice this straight away. They are really loud and will be bad to live near one. So another way to spin turbines is using moving water. So this just uses water movement to spin turbines, and it can be done in many ways, including water falling onto the blades of the turbine, as we can see in this bottom left image here. Water just flowing down that hill onto the water wheel, which is causing it to spin, and that spinning movement will produce electricity as long as there is electromagnetism going on in there. Ocean movement is another common way we can use this. As we can see in the bottom right, we're just using the flow of water. This is often can be done using tidal changes or the movement of waves. And this movement of water in the ocean spins the turbine, also generating an electric current. And the third way we can spin turbines is using steam. This is the most common method of producing electricity, and this involves boiling water and changing it into high pressure steam. This steam then spins the turbines, but the heat required to heat the water comes from many different sources, such as burning fossil fuels, examples coal gas, burning biomass, for example wood, sugarcane or methane gas, geothermal energy, nuclear power or solar power. These are all different ways we can use to heat water to produce high pressure steam to then spin the turbines. So that brings us to the end of our science lesson. Hopefully you guys can all now explain how electromagnetism works in generators, be able to explain how generators produce an electric current, and finally can describe different types of generators and how they work. Please jump onto Compass to see what to do next, and I'll see you guys all online.
2 + 2 is 4, -1, that's 3, quick maths.